Hi everyone, and welcome in section 4 of the course, which is variables and primitive data types, where this section will be in 6 parts. First, part 1 will be variables and data types, where we will learn about the concept of variables and data type. Then part 2, primitive data types, where the data types will be classified into two main categories, primitive data types and non-primitive data types. And in this section, we will focus on the primitive category. And in the next 4 parts, you will learn about the different data types under that primitive category. So let's start with part 1, variables and data types. But before diving in, let's see that example. Imagine you are a millionaire and your bank account is 1 million and you wanna make a program that prints out your account 10 times. So remember what we did in our first program in order to print something to the screen. First, the program will have at least one class, which is here called class program. And inside the class, we will have what's called main method with this format: public, static, void, main, and so on. Okay, so far nothing new. And inside the curly braces of the main method, we will put our code. So let's say system.out.println followed by parentheses, and inside the parentheses we have to put the double quotes, where what we want to print will go inside those double quotes. So let's print first hello, and don't forget to end the line with the semicolon, which acts as the period in the English sentence. And now run the program. Okay, and it prints the word hello as expected. But now let's print our balance instead of this word hello. So let's replace that with the balance 1 million. Okay, and we want to print that 10 times. Okay, let's copy that and paste 9 times more. 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay, now let's run the program. Okay, it works. It prints our balance 10 times. But after a few days and as many millionaires, your account is doubled to be now 2 millions instead of 1. And now we have to edit the amount of your balance in each line in the program. So we have to change that 1 to be 2, and that also to be 2, and that, and that, and that. And now run the program again. And yes, the value will be updated. But that seems hard and time consuming. Isn't it be cool if you could edit the value in just one place and then affect all the other places? Actually there is variables. Variables are like a representative for data it contains or holds. For example, your name is a variable that represents you. When you call a friend and tell him your name, instead of telling him details about you. So you don't have to say, hey, I am who is your friend since 5 years, when we was at grade 4 at school. Also I am the man who lives in blah blah blah. But instead you just tell him your name, and the name will describe everything about you. And the same in our example. We just have to give the account balance, which is 1 million, a variable name. And then everywhere the account balance is required, just replace it with the representative variable name for the balance, and it will do the work for you. And what's cool here, if you wanted to change its value anytime, you only have to change the value of the variable name, and hence its value will be changed in all places it's used at, rather than make it changing in every single place it's used. And that's why it's called variable. That's because its value can be changed or varies. So back to our example, let's give a variable name to our balance. So let's say we have a variable name, my balance, and to make it a representative for our balance value, we have to use the equal operator followed by the value. So let's say that the variable name my balance equals to 2 millions, and for sure don't forget to end the line with the semicolon. Okay, now we can replace the value 2 million with a variable name my balance that represents that value. So let's copy that. Copy and remove that and paste our variable name. Okay, let's delete that. And if you notice, we don't put the double quotes here, as we have made earlier, where the quotes will make the program prints what's written inside literally. So if we put that variable name myBalance between double quotes, the program will print the word myBalance instead of its value. So now let's run the program, and what we expect is that it prints the value 2 million, which is the variable name represent. So let's run. Ouch, an error. Why is that? That's because another fact about variables is that a variable is like a box that you could store anything inside. But does all boxes could be suitable for all stuff? I mean, could you use a small box as a box of your mobile phone to store your laptop? You can't. Also, it is not wise to do the opposite. To try storing your mobile phone in a big box like the laptop box, where that does not make sense. So, do you think a box to store your 2 million balance is the same as another box that can store $100? Also, it does not make sense. So, what makes error here is that you have to tell Java the type of box you would store your data inside, so that it will fit inside. And for that reason, Java is called strong typed language, because it cares about the type of variables or boxes to match the data stored inside. So, you have to precede the variable name with one of the data types. So to define any variable in Java, you have to put it in the following format: data type space variable name and equal to the value, where the variable name as the name myBalance we have chosen in our example, and the value as our balance value, which is 1 million. But what about the data type? What are the different data types in Java, or say box sizes? So we can choose among them for our variables. But let's answer that question in the next video.